And we are back, and we are going to look at TG and specifically how the chemical structure of monomers can influence the glass transition temperature. So remember, we need to basically go beyond that glass transition temperature. It's the cooperative molecular motion of 10 to 30 connected monomers, so to collectively move. So the TG can be influenced strongly by chain interactions. So basically those are intermolecular actions between your monomer units. The ease of rotation around those main bonds. So again, those intermolecular interactions, you're looking at things like H bonds. You're going to also look at, again, those amide groups. We all know one chemistry from this course. You can also have polar interactions, so anything with a fluorine, anything, if you see an oxygen, a nitrogen, chlorine, etc. You can also have steric interactions, so big, bulky, molecular groups. Those are going to not want to be near each other, and van der Waals interactions as well. So intermolecular interactions, those will affect TG. Stronger the interactions, higher the TG to break those and start to move collectively. You ease rotation around the backbone. So this polyethylene group versus this group or this polymer monomer unit that has these big, bulky aromatic rings or phenyl groups. Actually, no, those are actually aromatic rings. Amides, so that is going to be very difficult to rotate around with all those carbon-carbon double bonds. And then how densely the material is packed. So if I have a more flexible material like polyethylene, my TG is minus 80 versus PVC. All I'm changing is a Cl. I have a polar group. That is a 160 degree C swing. That's enormous by just changing one molecule. You can see here, PDMS, minus 123 all the way up to 150 for polycarbonate. Why? Rigid backbone, has those polar oxygen groups, has the methyl group CH3 there, sandwiched in between the aromatic rings. So more stiff backbone, higher TG. More interactions, higher TG. More flexible backbone, lower TG. No or weaker interactions, or less or fewer intramolecular interactions, lower TG. So that's kind of how that molecular structure can influence TG. So next time we are going to get into our models. See you then.